Okay, so today we want to learn how to find limits of polynomials and rational functions, okay? So this is kind of a review right here, the first slide here, okay? You guys know that this is a polynomial, and this is what I used to call a red func. Remember that? Red func? Okay, so red func is poly over poly. Okay. Now, by and large, well, for polynomials, finding limits is just going to be plug it in, plug it in. Okay? For rational functions, that might not be the case. Why? Why do you think that might not work? It'll work sometimes. That's right, because if you plug in some number, whatever that number happens to be, and if this guy becomes a 0, then nasty things happen. So you got to worry about that situation. Okay? All right? So, again, this is just a review to tell you what are polynomials and what are rational functions. Oh, I forgot my mouse here. Okay, some nice rules to find out limits of polynomials, okay, and rational functions. So take that down. It looks really intimidating. The bottom line is, what's the bottom line?
It works.
Another favorite saying of mine.
Sit down, shut up.
No, not that rude. Something really practical. Huh? No, just plug it in. Yeah, just plug it in. Okay, so plug it in, plug it in. Okay. Look at the caveat there, okay? That the denominator cannot be 0. If it is 0, then we've got to worry about it and think a little bit more. Okay, think a little bit more. If it's not, then hey, that's pretty easy. Awesome, you're pretty chirpy today because it's min day.
Huh?
Pretty chirpy today. It's minimum day.
Yeah.
Yeah. Okay, everybody got this down? Right? Okay. Well, go do it. Go do it. Oh, what? Plug it in, plug it in. What'd you get? Oh, what? -4. Okay.
Nice try.
I'm smoking, sorry.
That's okay.
And then the second one? Second one?
Oh, I was just
Second one? Sorry, beta? -3. Beta is getting -3. Is everybody okay on that? Right, just plug and chug. Does anybody want to see the work done?
Wait,
Yeah?
you
Did I hear someone say yeah?
I got negative.
For the second one? For the second one?
What have you tried here?
Well, it's right here. So you're going to get -1 squared -1 -6 over -1 plus 3.
That's plus
Which is, huh? Yeah, so this will cancel. So it gives you -6 over 2, which is -3. Okay? So these worked out nice. Plug and chug because the denominator didn't go 0, so no sweat. Okay, no sweat. Now, what happens if the denominator does go to 0? And we've done this kind of problem yesterday, okay? We kind of did it yesterday as well. And it tells you what to do, okay? It tells you what to do.
We can use the n function on the test.
Yeah, unfortunately you can.
Awesome.
Yeah, my calculus class, I use NBox all the time. So any test, any quiz, graphing calculator is okay. And then I don't even expect students to memorize formulas. Everything is given. Or there are handouts and things like that. So it's done very differently.
That would be wonderful.
Yeah, it's done differently because remember, the goals are not AP. So, I can do it the way I want to do it.
Is there an AP goal?
No, but this one's getting you ready for AP.
Oh.
It's pre-calc. It's getting ready for calculus. So. Okay, is everybody all right on this? Do I need to explain this?
You just got it, right?
No, you factor it. Okay, right there. Okay, so you factor this guy, which gives you x plus 3 times x minus 2. Then you cancel the factor. And then it leaves you with a simple polynomial, does it not? And for polynomials, there's never an issue because there's no denominator. So you can always plug it in for a polynomial. And so then this one would give you -5. And I'm asking you to check using the n box. So what I mean by that is put this in your graphing calculator, graph that, and follow the process that we laid out yesterday. Okay? So graph that and follow the process we laid out yesterday. Okay, is everybody all right there? Sajal, you got your graphing calculator? Sorry, graphing calculator. Done it? Soleil, done it? Yeah. You can factor and do stuff with it. Okay? Okay, how about you trying this example? So if I factor this, I get 1 minus 3x, 1 plus x. Does everybody buy that factoring? Over 1 plus x. Is everybody okay on that? Then I can cancel this. And then I get limit x goes to minus 1 of 1 minus 3x. And now it's safe to plug it in, And if I plug it in, I get a 4. Now the thing that I want you to observe is notice that I continue writing this stuff. I continue writing it until I just get a number, and then I don't need that limit because the limit is a number. Okay? Is a number. So please make sure you have a limit as you go work this out, okay? Don't be lazy and not put this, okay? You will get points taken off if you do that. Okay? All right, is everybody all right? Now the very famous problem from calculus. It's called a tangent line problem. So this is really the absolute beginnings of calculus. The absolute beginnings of calculus. I don't know how many people recognize this, but this kind of question was on one of the SMAs. Without that, that was an SMA question. And we have done this before. We did it somewhere in chapter 2 or something like that. H goes to 0.
Oh, yeah.
And this is the key concept here, okay? This represents the slope of a tangent line to a curve. Get this down and then I'll start explaining what I'm saying. Okay, everybody got this down? Yeah? Okay. Take this down and I'll explain that. So here's a graph, okay? Does everybody buy that? No? Okay, well, let's think about it. Let's think about it, okay? Do you agree that this distance here is fx plus h? Let me erase some stuff, okay, so it's not very confusing. Does everybody buy that? This distance here is fx plus h. Because remember what I told you yesterday. A function value is the y value, isn't it? Well, isn't the y value the distance from the x-axis? Right? Everybody with me on that?
Didn't you already label that from B to the...
Okay, be very careful, okay? The blue line is running short. It's not going to the x-axis. This blue curve that I have here, I'll show you in a minute what I'm saying, okay? All right, so if I take a look at the blue line, I'm going to put it right on top. Oops, my bad. That's not where I wanted. Okay. Do you see this little distance here? Can you guys see that?
Yeah.
This little distance here. Okay. That, fuck. That is f of x. Okay, that is f of x.
Yeah.
Do you see that?
Yeah.
Remember, f means the y value. Okay? What's the y value at this point? fx. Okay, so if you draw a horizontal line here, okay, then this distance has got to be fx. Right? This distance here from the top all the way down to the bottom is fx plus h.
What is it?
You guys, let me finish this, okay? So you've got this. Let me put it in the right colors here, okay? So I've got this distance here is fx plus h. Okay? And then I've got this distance here that is fx.
Oh.
You guys with me on that? So then, what is this distance here from there to there?
H.
No.
So the FH.
Whoa, this is fx plus h.
Oh.
This is fx.
fx plus h minus.
Thank you. Okay, fx plus h. Remember, fx plus h is some number, right? It's the value of a function. It's some number minus fx.
Yeah.
Does everybody see that? Is everybody with me on this now?
Because it's a triangle.
Not yet? Okay, let me ask you this question here. I'm telling you that this is 5. And then I'm telling you that this is 3. Then tell me what this is. 5 minus 3? Right? You got this distance, and then you're going to take this much out of there. Well, then it's going to leave you 5 minus 3. You with me on that? Yes? Laura, are you here? It's like instead of doing it like this, I've turned it vertical.
But I'm still here.
Well, the point I'm trying to make to you is that, do you see that it's going to be a difference? 5 minus 3. Okay, if you agree that it's going to be a distance, then it's going to be a difference, then that's exactly what I'm doing here. Except instead of numbers, I've got symbols. I've got fx plus h all the way from there to there, and this much is fx, so then this has got to be the difference of the two quantities. I'll have to do something different and show you how it is. I'll probably have to get a string or something and show you what I mean. Okay. All right, is everybody okay on that? Okay, then take a look at this. Look at what we had earlier, okay? Oops. Where are the windows? Oh, well. Okay, let's go back in here. Okay, so keep this equation in mind. Don't forget that. Keep that at the back of your mind, beta. Keep it at the back of your mind, okay? So I have fx plus h minus fx over h. This is a right angle here. Okay, let me erase a lot of this stuff, okay, because it's just coming in the way. Okay, you want to erase that for me, sweetie?